Hi, in this video we are going to see how we can extract metadata out of different documents and also chunk it for better query results. Before starting, let's get into some terminologies that we need to understand before understanding the whole process. So first is the metadata. What is metadata? So every documents have different kind of details such as page numbers, elements, file types, which can be used for better output from the query that user is giving. So document details provides the additional information about the content extracted from the source document. There is structure metadata, for example, element type, hierarchy information, and section information. So that there are like different kind of metadata associated with different type of files. Now what is semantic search? So given an input text, we can semantically find similar content based on the query which user has provided. So it is in the form of vectors. So internally vector database are built in a way so that it can find similar queries which are near to the query which user has searched for. So there are different kind of vector databases which are used such as Pinecone and ChromaDB. Now let's talk about hybrid search. So in the previous slide we have seen what is semantic search, but semantic search also don't works very good in like all cases. So there is a concept of hybrid search. So what are the problems and challenges in semantic search? Too many matches. In case we have like a large number of documents, there can be so many matches that we actually don't want. Most recent information, user may want to retrieve the recent information, and which in case of semantic search we cannot get. Loss of important information such as section information can be lost when we are only doing semantic search. So here we are also going to see how we can do the hybrid search. But what is hybrid search? Is a search strategy that combines semantic search with other information such as filtering and keyword search. So this is the example of most recent information. If a user has queried about Super Bowl and there are like multiple documents, so using a hybrid search we can retrieve the most recent document, in this case which is Feb 12, 2024. Now let's talk about chunking. So first of all, let's talk about why is chunking required. For example, if you are not doing chunking, and we know like all the LLMs have a small context size, and we as we increase context size, the cost of the model will increase per inference, and also it would take more time for training. So in that case, we do chunking. So chunking is basically transforming all the elements into small chunks or into small sizes which has some coherent relevance with each other. So what is the chunking necessity? Vector databases need documents split into chunks for retrieval and prompt generation. Query result variability. The same query will return different content depending on the chunk. So for example, the chunk size is different. In some case, maybe it could be like some maybe 1000 characters. So the query which user is giving, it can differ in terms of the output based on the chunk size. So there are different kind of techniques which can be used for chunking. One is even size chunking. That is the easiest way to split the document roughly into same size of chunks. This can result in similar content getting split across chunks. So ideally we don't want some similar content to be chunked into different pieces. Ideally the same kind of content should be ideally chunked into the same chunk. Chunking by atomic elements. By identifying atomic elements, you can chunk by combining elements rather than splitting raw text. So basically it is saying using some metadata or using some other property, we can identify what kind of content belongs to the same chunk and then create chunks out of it. So here we can see how we can construct chunk from document elements. So partitioning is the first process in which we break down the document into atomic elements. Then we combine the elements into chunk. Add one document element to the chunk, continue adding document to the chunk until you have reached a character or token threshold. We can also apply some break condition. For example, if we see there is a new title coming, or maybe if we see there is a new page number, we can apply a break condition which would stop chunking the element and move to the next chunk. Combine smaller chunk. Optionally, we can also combine small chunks, so chunks are sufficiently large for effective semantic search. So if our chunk size is like really small, the search output won't be that great. So in this case, we see like an example. If we are doing character level splitting, in which we set a maximum threshold of after how many characters we should create a new chunk. So in this case, it would be of this type, like the first half of the document in one chunk and second half into the other. But if we have chunk based on the document elements, in this case by title, so all the content within the one title belong to one chunk, and all the content belonging to other title belongs to other chunk. After covering the main concepts which are required for metadata extraction and chunking, let's dive into the notebook. First of all, we are filtering out the warnings. We are setting up the logger. Then we are importing different functions from the unstructured library. Also, we can see like we have added one new import, which is ChromaDB, which is used for in-memory vector database. Then we are setting up the API keys. Now we are going to see a screenshot which we are going to split and do chunking. So the screenshot that we are going to see is of this PDF file. Winter Sports in Switzerland. This is a book which we are going to extract the metadata out of from and also do chunking. You can also see in this image there is like a contents page which is showing different kind of chapters. Now let's run the unstructured API on this book. So using this request, we are going to like request the unstructured API to give us the response, which would contain different elements from this book, and let's see those elements in form of a JSON. So you can see there is title and there is the text, there is narrative text. So we now have retrieved the elements from the book. Now let's connect or map elements with different chapters. So you can see there is one title called Ice Hockey. So Ice Hockey is like one of the chapters within the book. We have written down all the chapters here. And now what we are going to do is we are going to map all the element IDs with the chapters. So as you can see, we have the chapter IDs and the chapter names. Now we are iterating on the chapter IDs. And for each chapter ID, we are also seeing the element ID. Now we are going to load all the elements into the ChromaDB, which is the vector in-memory storage, vector database. We have to now create a collection. Name of the collection would be Winter Sport, and the metadata which we are providing here is the cosine similarity which is on this vector space. After this, what we are going to do, we are going to insert all the elements into this collection. So we are going to iterate on the elements that we got from our response. We are retrieving the parent ID and also the chapter, and in the metadata we are inserting the chapter along with the element IDs and the document text. Once this is done, we can also peek into the vector database. So this cell is still running, which is inserting the data into vector database. Once these elements are inserted into the vector database, then we are also going to do a hybrid search with metadata. So as you can see, how many players are there on the team, and here in the query we have provided a where clause where chapter is equal to ice hockey. So this query is going to search for all how many players are on the team and within the chapter which is associated with ice hockey, and we have filtered out the sample space which is required for the search. After that, we can also chunk the content. So we have created a dictionary out of all the elements. Okay, I think the previous queries have now been completed. So this is like a sneak peek of all the results which are stored into the vector database. After performing the vector search, you can see it has returned some results. Since the number of results were equal to 2, it has returned 2 IDs, distance, it's the cosine similarity, and the documents which were relevant to the query, how many players are on the team. So this is how we can query the vector database. Now, if we want to chunk the content, we are first creating a dictionary out of all the elements. Then we are chunking it with title, and here you can see there are 2 other parameters, combined text under n characters. So we can define the min and max limit based on the characters for the chunk. In this case, it is the minimum number of characters that should be into a single chunk is 100 and the maximum characters is 3000. So this is how we can define the max and min limit of a chunk. And then we have created a JSON dump out of it to see how our chunk looks like. Now we can also see how many elements were there before chunking, and once we have done the chunking process, you can see the number of elements which were there into the extracted data have now reduced to 255. So we have now 255 chunks which are stored like in any place that we want and which can be queried by any LLM system. So in this chapter, what we have seen is how we can extract metadata out of the file that we are using, and also how we can chunk our data for better extraction and also to make our LLM model inferencing cost effective.